UTME Physics practice problem. Question number 1 here says that a 25 Newton force pulls a 2 kg body up a 30 degrees inclined plane. If the force is parallel to the plane and the body moves up the plane at a constant velocity, calculate the magnitude of the frictional force between the body and the plane. So the first thing I'm going to do is that I'm going to draw the inclined plane. The inclined plane is at 30 degrees to the horizontal. Now, whenever you have a problem like this, you try to draw all the natural forces that are acting in the system. And you start with the body itself. The body is a body of 2 kg. So let's say the body is like a box and it is resting here. So I'm going to align that to rest on the plane. Yes. Now, so for the body itself, it's going to have its weight acting downward. So you draw it, the weight is acting downward. Since the mass of the body is 2 kilograms, then you multiply by acceleration due to gravity, which is 10 meters per second squared. So that implies that the weight of the body is 20 newtons. And the next one is that there's something called normal reaction. When you hear normal in physics or math, it means perpendicular. So the normal reaction is going to be acting perpendicular to the surface of interaction between the box and the plane. And this is going to be the normal reaction. And the next one is the force itself. The force is pulling it up. So you have the force 25 newtons acting upward here. Lastly, we are told to find the frictional force. Friction always opposes the direction of motion. So the intended direction of motion of this object, or in fact the actual place it is moving towards, is up the plane. So therefore, the frictional force is going to be down the plane. Now, when we are done with this, what we need to do now is that we need to find a path of this R downward as well, because we need to know the angle that the inclined plane is making. The angle that the weight is making with the path of R. That is going to be needed, and that angle is also going to be 30 degrees. So just think of that. The weight that is acting downward and the downward part of the normal reaction will have the same angle as that of the incline. I'm going to show you that very soon. So now the next thing you want to do now is that you want to make the R path, where you have your normal reaction, you want to make it the vertical component. And so this other part with the 25 newtons and the frictional force is going to be the horizontal component. I'm still going to show you what that actually is, how we are doing that. So when you notice that at the top here, you have the normal reaction. Here you have the 25 newtons. Here you have the frictional force. Now, just in between the frictional force and the downward part of the normal reaction, you have the weight acting, which is what? 20 newtons. And the angle is made between the 20 newtons and the downward part of R, so which is 30 degrees. So to show you what that is from your point of view, I'm going to rotate this entire guy. Okay, I think I have to take this R down a little bit. Yeah. So let me rotate this and show you what exactly I've done here. So what I've done here is that I've done this. Yeah. So if you look at that, you see that R is up and then FR is to the left, 25 Newton is to the right, and 20 Newton is just in between that. So that is what I've done with this inclined plane of a thing. So now let's resolve this, guys. Now, to the horizontal, we have three forces in the horizontal. We have the 25 newtons, the frictional force, and we have the 20 newtons. This 20 newtons has both horizontal and vertical components. So let's do that. On the right, we have plus 25. Left, we have minus frictional force. And then we have what? Minus 20. But we have to determine whether we're to use sine or cosine. So to use sine or cosine is not really about, oh, one is vertical is always sine or horizontal is always cosine. That is not true. You ask yourself a question. Which axis am I dealing with? In this case, I'm dealing with horizontal. Which axis is the angle made with? The angle is made with the vertical. When these answers are not the same, that is, yeah, I'm dealing with horizontal, the angle is made with the vertical. Whenever that is the case, we always use sine of the angle. So that will be what? Sine 30 degrees. But if the answers are the same, we use cosine of the angle. So in this case, normally this is supposed to be equal to mass times acceleration. That is, this is the net force in the horizontal direction. It's supposed to be equal to mass times acceleration. But because the question told us that this body moved with a constant velocity implies that the acceleration is going to be equal to 0. So therefore, everything here, which is 25 minus frictional force minus 20 sine 30 is 10. Everything is going to be equal to what? 0. And here, if you solve it very well, 25 minus 10 is 15. newtons, then minus frictional force. If you take it to the other side, you have frictional force here. That implies that the frictional force here is going to be 15 newtons, and that is the solution for the frictional force. Of course, you can go ahead and use what I just explained now to do for the horizontal. There are only two forces in the horizontal, the normal reaction and the 20 newton weight. So I'm not going to do that because I've already solved this particular part of the problem. So the answer is 15 newtons. Quickly, let's go to number 2. Which of the following must be true if the net force acting on an object is 0? Now, for the net force acting on an object to be 0, what it simply means is that F net equals 0. And normally F net force is supposed to be equals to mass times acceleration, just like I showed you here. So there are two conditions for acceleration to be 0, because mass is not 0 as long as the object exists. So for acceleration to be equal to 0, that means that the body is at rest, or the body is moving with constant velocity. So any of these two conditions will make us have 0 acceleration. So let's now see. Remember, if we want to see that if the net force acting on an object is 0, then the object is at rest. While this is only partly true, it doesn't satisfy what we are looking for in this place, because it says which of them must be true. And it is not necessarily that the body must be at rest, because an object can be moving. As long as it is moving with constant velocity, then it will have 0 acceleration. So saying the object is at rest is a must for the body to have a net force of 0. That is not going to be true, even though it is partly true. Now, Roman figure 2 says that, so we can rule that out. Roman figure 2 says that the object has a constant velocity. Yes, that will be our guide, because constant velocity can apply for when you are at rest. When you are at rest, your initial velocity is 0 meters per second. You've not moved. Then your final velocity will also still be what? 0 meters per second. So with this, you have 0 acceleration. But you can be moving. Let's say your initial velocity was 20 meters per second, and your final velocity also 20 meters per second. That is, you are moving with constant velocity. Then your acceleration will still be what? 0. So this one is an all-encompassing statement. It takes care of when you are at rest, and it takes care of when you are moving as well. And number figure 3 says that no forces act on the object. This is also not true, but it is partly true anyways. If no force is acting on an object, then the net force on it equals to 0. But let's say in a situation where you have, let's say I have a force of 15 newtons here, and a force of 20 newtons here, and a force of 35 newtons to the right. Now, what you notice is that the sum of left force is 35, sum of right force is 35. They cancel out, and the net force will be equal to 0. So meaning that it's not necessary that, oh, no force is acting on the object. That is why the net force equals to 0. Forces can be acting on the object, and the net force will still be 0. So we rule this one out. So the only correct answer there is Roman figure 2. Okay, let's see if we can quickly answer question number 3. I think I'll answer that in the next video. There are actually 70 questions here, so you want to make sure that you're following me, and then you want to make sure that you comment and like, so that you can always see my subsequent videos. I will be posting the subsequent ones later. We have 70 questions. In the next video, I'm going to be covering more questions. So make sure you like, comment, and follow me. I'll see you in the next one.